Hello students, I'm sorry to not be with you again today. Still trying to break this fever and get well. So here's your lesson for today. It is 6.3, it's rotations. In my opinion, the most difficult of all of the lessons that you will have in this chapter. Now remember, after this one we only have one more. So the idea is we're going to spend at least 2 days on this particular chapter, and you're going to notice that the presentation of this lesson is going to be a little bit different because it would be easier for me to explain in person. So because I'm not there, I'm going to try to give you a little bit more visual assistance so that you can have some success with this. So first things first, let's tackle this quick check. It's just 2 problems. I pulled them from the end of the last lesson. You should be working on translations. Specifically, these would be well, you figure it out. Quadrilateral ABCD has vertices that are right here. Find the vertices after each translation of the prime letters. Come back and check those in a couple minutes. So remember that you can accomplish translations by adding or subtracting to the x or y coordinates. So 4 units up, we should be adding 4 to the y. So that give you negative 5, 3, negative 3, 4, 2, 2, and 0, negative 2. For the number 15, 2 units right and 2 units down, that means add 2 to the x and subtract 2 from the y. So that gives me negative 3, negative 3, negative 1, negative 2, 4, negative 4, and 2, negative 8. Okay, go back and check any of those if you need to. Pause and feel free to do that. Otherwise, we're moving on. So as always, our essential question, how can we best show or describe changes in position of a figure? Today we're looking at rotation. Rotate a figure about a point, in other words a fixed point on the graph, and how to rotate a figure about the origin. So you'll notice that these are both fixed points, and sometimes it'll be a point that is actually on the figure, and sometimes it will not be. It'll be on the origin, and we're going to realize how to do both of those. So here's your vocab. I already have it completed for you, and I used a picture from your textbook to hopefully explain it a little bit better. I know it takes up both spots, so just bear with me there. First of all, rotation is a spin. So in other words, we're spinning a figure around a fixed point. So if you think of a clock, I know we have a digital clock in the room, but if you can imagine what they call an analog clock, which is with the hour hand and the minute hand, and they go around in a circle, that would be rotation, those hands going around the clock at different hours and minutes of the day. So that particular fixed point would be the middle of the clock, right? And then the hands are going around that fixed point. Okay. In this particular example here, the picture, the original figure, the pre-image, is this blue triangle. Okay. And the rotation is that it is spinning. In this case, it says 180 degrees. So you're going to learn a little bit about the rotation angle, or angle of rotation. We talked about that yesterday in the intro video. So it's 180 degrees, and this is also counterclockwise. Okay, so you need to understand the difference between clockwise and counterclockwise. If you are trying to tell time on an analog clock, time goes this way. The hours and the minutes go around like this. So if you start at 12 o'clock, and it goes around to the right, 12, 1, 2, 3, 4, 5, etc. The opposite direction would be counterclockwise, just to clarify. So the green triangle is the image. It is the rotation of the blue triangle 180 degrees counterclockwise. The center of rotation is the fixed point itself. So whatever fixed point the figure is rotating around, that's called the center of rotation. And again, it can be a point on the actual figure, which in this case it is. This is rotating around point L, as you can see. Or it can be the origin. So the center of rotation here is point L, that if you can imagine putting your pencil, like if you had a cutout piece of a triangle, piece of paper, and you stuck your pencil down to hold it, and you rotated it downward while keeping your pencil in place right at that top corner, that is one way that you could accomplish this rotation. So not really heavy vocab, it's pretty self-explanatory. Now the presentation itself for the rest of the lesson is going to look a little bit different. So I am going to get set up here, take a couple of minutes to review the vocab in this picture, and then we will move on. Okay, so these slides are going to look the same on your packet, although the actual presentation is going to be a little bit different, and you'll see why I'm doing it this way for today. just to give you some more visual examples. So here's your key concept. Rotation is about the origin. It doesn't talk specifically about the fixed point on the figure, because in my opinion that's a little bit easier. Origin is more difficult because it just is. It's less intuitive. So what you're going to see here is that there are three different types of rotation in this particular case around the origin that we're going to be talking about. It doesn't mean that this is the only types of rotation or that these are the only types of rotation. It just means that these are the three we're going to be looking at. So in multiples of 90, so 90 degrees clockwise or counterclockwise, 180 clockwise or counterclockwise, and 270 clockwise or counterclockwise. And again, this is around the origin. So just a quick friendly reminder, the origin is 0, 0. And there is a certain strategy that you can use in order to do this. And in fact, while you are at this point of the video, I would like you to pause this and go over to the big cabinet underneath the clock and go in there and get a protractor out of the blue tub so that you can continue this lesson. Okay? And if you need proof that you're allowed to get out of your seat, just play this part of the video. So this is example one. Again, you have this on your packet. It just looks a little different on my screen. The reason for that is because I'm going to try my best to give you the step-by-steps, because it would be easier if I was there. So I'm trying to do the best that I can for you. So anyways, triangle LMN with these vertices represents a desk in Jackson's bedroom. He wants to rotate the desk counterclockwise 180 degrees about vertex L. Graph the figure and its image, then give the coordinates of the vertices for L prime, M prime, N prime. So you'll notice that this looks very similar to the other transformations that we've done so far, where the first example requires you to graph the original figure or the pre-image, then graph the image after the transformation has taken place, and then finally find the coordinates of the new figure or the image. So we're going to attack that by doing the following. And again, you have this axis on your paper. So the first thing we need to do is graph the original figure. So go ahead and graph LMN. Pause if you need to. So a couple of vocabulary situations that you need to be aware of. First of all, the direction, which in this case is counterclockwise, and the degrees, which is 180. So that means two things to us. First of all, it means that I'm going to be making a 180 degree angle this direction, rotating that figure around, and also about vertex L. So point L is going to be the fixed point or the center of rotation. Okay? And you can kind of imagine what's going to happen here. If I spin this thing all the way around this way, this part, MN, is going to be at the bottom, pointing the other way. And I'm going to have the hypotenuse of what this appears to be a right triangle going this way. So let me erase what I have up here, and you'll be able to do that. So done. Graph the rotated image, and it says to use a protractor. So I'm not really sure personally if it is as necessary to use a protractor for the fixed point on the figure as it is for the origin problems, which we'll get to. But at any rate, here's the basics of how to do this. It says use a protractor. So here's what I'm going to do. I'm going to put the center of the protractor on L, the dot. Okay, and I want to make sure that the curvy part of the protractor is facing this direction. Okay. And then what I want to do is I need to know the length or the distance of this side right here, which appears to be 1, 2, 3 units. And I need to make a ray, it's called, a segment, 1, 2, 3 units in this direction. So in other words, 180 degrees around. That is the same length. Okay. I don't want to give you too much to think about, and I could have explained it a couple of different ways, but that is kind of the most direct way to do it. So at any rate, we're going to rotate. So your protractor looks like that pink half circle. All right, so the circular part should be at the top. The point is right on the L, and you're drawing this segment here on the bottom because that's 180 degrees around. right? And that's M prime because it's this point rotated down there. Also, while you're at it, you can label L prime because it is the same as L. If I'm rotating around that fixed point, this is L and L prime. Next, we're going to do that for point N. Okay, so you can kind of imagine that when you spin it, and this is where it kind of gets visually a little bit more challenging. If I spin it this way, right, the point is going to be sticking out toward the left now instead of to the right. This side is on the top, this side is on the bottom. Here's the hypotenuse, here's the hypotenuse, and you'll notice that this 1, 2, 3 unit distance right here is the same as this 1, 2, 3 unit distance down at the bottom. And it mentions that N prime is going to be right there, and then all I should have to do is connect the dots and identify where those coordinates are. So L prime is the same as L, so it should also be 5, 4. M prime is right here, 1, 2, 3, 4, 5, 1. N prime is 1, 2, 1. So again, I'm going to be writing those coordinates down at the bottom. I don't think it's necessary to write all of this word for word in terms of the steps. I just wanted to give you a good enough explanation because I'm not there to, kind of make it shorthanded, and I don't want to confuse you and have this be a waste of a day for you either. So hopefully that makes sense, and in my opinion this is easier than rotating about the origin, which we'll get to in a minute. So again, if you need to play any of that back, this would definitely be a lesson where you should feel free to go back and rewind, play this over and over until you get it. And then what I'm going to ask that you do as I switch this page here is do your best to try this on your own completely and then come back for the explanation. So I'd pause the video now, come back for the explanation after you have tried it yourself. So there you have it. Here is the image. The gray part, the lighter part, is the image after the rotation. The black triangle is the pre-image. So what has happened is it has been rotated 90 degrees clockwise. So clockwise, 90 degrees about J, which means J is the center of rotation. So this triangle should be going that away. And what this would require is, you can see the angle kind of symbol there that I made with my arrow. So what it would look like actually is if I had my protractor out, I would set my protractor, again let me erase what I have here so it's a little bit easier to see. I would set my protractor so that the bottom part was on this line like so. Whoops, that's not. Hang on a second, clear this away. So for K, I'm going to put it on K, like that. And I'm going to have to rotate K 90 degrees from there, which means so apologies there. The rule is that the protractor must go on the point of rotation. So how do I know which way it's going to spin? Well, here's the thing. You have this, you're trying to rotate, point K, right? So point K is below point J according to the graph. So I need to line up the protractor so that the bottom part of the protractor is on top of this segment, JK. The dot needs to go right on the vertex, the center of rotation, point J. And then if I start down here, this is 0, and the thing needs to go all the way around to 90 degrees. And if you do that, then you're going to end up with point K prime rotating all the way around 90 degrees. And remember that it needs to be the same distance. Okay, so you're rotating at about point J. So this distance here is 1, 2, 3, 4 units. And this distance is 1, 2, 3, 4 units for point K prime. Alright, it becomes a little bit easier to do the other ones when you have the first one done, in my opinion again. So let me clear this off and kind of see what we're working with. So let's say right now we have this situation where we just have the K prime up there and the J prime. After that, all you really need to do is visualize, okay, it's going to rotate 90 degrees that way, which means if I rotate a horizontal 90 degrees, now it's going to be vertical. And this distance is 1, 2, 3 units. So I'm going to have to go 1, 2, 3 units up and put my dot here for L prime, right? And then if I connect those dots, the only thing left to do is connect the dots to make the rest of the triangle. And then here's L prime right there. And J prime I already have. K prime was the first point that I plotted. And the coordinates of those new points, the prime points, are right here. 3, 1, negative 1, 1, and negative 1, 4. Again, I know this is probably a little bit more confusing than you're used to. And again, I'd be able to explain it better if I were there, so I apologize for any confusion so far. If Mr. Hernandez is in the room, he'll be able to help you as well. And obviously I can clean up any messes when I come back tomorrow. Other than that, though, we're going to move on to the next example. So if you need to, again, rewind and play this back a couple times, please do that before moving ahead. This is example 2. Triangle DEF has these vertices. Graph the figure and its image after a clockwise rotation of 90 degrees about the origin. Okay, about the origin. Then give the coordinates of the new figure. So, how does that work? Well, first we're going to graph the original triangle. And it looks like that, DEF. Like so. And this happens to be another right triangle. It could be any shape. Doesn't have to be a triangle. Certainly doesn't have to be a right triangle. It's a little bit easier when they are right triangles, but you should be prepared to rotate any type of figure, any shape, no matter what. Alright? So there's my original figure. After that, here is how I rotate about the origin. You are going to use your knowledge of angles and your knowledge of the origin to understand what is happening. So this is where it can get a little bit more confusing. So let's take it one step at a time. Here's the origin, right? 0, 0. There's the origin right there. Okay. So just like with the previous example, I need to know what I'm doing and what direction. So clockwise, 90 degrees. And of course, this time we're going about the origin. So you'll notice this pink angle represents a 90-degree angle from point E, okay, going through the origin. It says sketch segment EO. Alright, so you're going down here to the origin and then sketch another segment E primo so that the angle between these angles is 90 degrees and the segment is the same length. So these two segments are the same length. We can use distance formula to do that, right? But this one, well, you can see 1, 2, 1, and then 1, 2, 1. That's how that works. 90 degrees, 2 units vertical, 1 unit horizontal. So then 2 units horizontal, 1 unit vertical to make my 90-degree angle. After that, that, by the way, tells you where E prime is going to be. After that, you're going to repeat that for the other 2 points. You're going to take point F, and if you'll notice, I kind of have to draw it. You're going to construct a 90-degree angle. So first of all, you draw, let's use red, so that it looks like they're pink. You draw, connect this segment to the origin, okay? And you'll notice that it is 1, 2, 3 horizontal and 1 vertical, which means if I'm going to go this way, make my 90-degree angle across the origin to connect up here, there's my 90-degree angle, right? It looks like this. And you'll also notice that it is 1, 2, 3 units by 1 unit. In order for this to make a right angle, it has to, the x's and y's have to be the opposite. So in other words, this was 3 units in a horizontal direction, and this was 3 units in a vertical direction. That's the way that it needs to be in order to form this right angle. So that allows me to plot this point F prime. I already did E prime. Let me erase and we'll do the D prime. So if you think about it, D is going to make a 90-degree angle like this. So come all the way down this way, all right, to the origin, right? It's a diagonal line. All diagonal lines have a vertical and a horizontal distance. So this horizontal distance is 1, 2, 3, 4, and the vertical distance is 1, 2, 3, 4, which means from this point I'm going to go 4 by 4 to make my D prime over here. So 1, 2, 3, 4, and 1, 2, 3, 4 to make D prime, and make sure that there's my 90-degree angle right there. So a little tricky, a little time consuming, but hopefully you get that idea. And then here is your image. And you can kind of see, it is rotating 90 degrees clockwise, so it's going that way. And it's going about the origin, so it's kind of, if you want to think of it like revolving, it's revolving around the origin while it's rotating, kind of like the Earth. It rotates on its axis while it revolves around the sun. That's sort of what the idea is behind a rotation about the origin. Kind of the same idea. So as it is spinning, it is also moving in a circular pattern when it's going about the origin. So the origin is the sun. Your figure is the Earth or any other planet, if you prefer a different planet. And this is the orbit around the origin. Okay? Again, if you need to rewind, play it again as many times as you need to. Don't be in a hurry. Don't leave today not having some clue as to how to do these problems. Oh, we forgot to label the points, didn't we? So let's do that. The new coordinates. That's probably the easiest part after you have done all of the drawing. It's identifying the coordinates. So you've got D prime is 4, 4, E prime is 2, 1, and F prime is 1, 3. So there you have it. So the idea here is with the next example, you want to try to do this one completely independently. I realize it's a challenge. See what you can do on your own, and then check it with the answer when you are done. Take a couple minutes. So maybe it's appropriate to attack this from backwards to forwards. In other words, you have here's the original. Here's what it looks like after it's been rotated. And again, if you think of it in terms of this thing is going around, it's revolving around the sun, going around the origin. That's maybe a helpful way to visualize what's going to happen. So let's draw our 90-degree angles, which is the strategy for this particular concept. So first of all, I need to know which direction I'm going, counterclockwise, and how many degrees, 180. And obviously it's about the origin, so I'm using my point 0, 0. 180 is actually a little bit, I don't know, easier, harder, well, you decide. So if I connect point C to the origin, okay, tell me about it. I've got a vertical change of 1 and a horizontal change of 2. 180 degrees means that this is going to continue this direction for the same distance. In other words, another 2 in a horizontal direction and 1 in a vertical direction. That's where this point C prime comes from. So here's my 180-degree angle right there, right? That's 180, a straight line. I'm going to do that for the other points, but it has to go through the origin. So let me erase this so we can look at B prime. Again, it's going to go from B to the origin, right? That looks like 1, 2, 3, 4 vertically and 1 horizontally. So 4 by 1. Which means it needs to continue this way. 1, 2, 3, 4 by 1. So it's going to continue through the origin in a straight line. That's not a very good drawing. You get the idea. Here's my 180-degree angle. There's point B prime. Lastly, for point C prime, here's C. Oh, I did C already. A prime. A to the origin looks like that. A horizontal distance of 1, 2, 3, 4. A vertical distance of 1. So 1, 2, 3, 4, 1. It's going to continue through the origin to that point. Again, not the best drawing in the world. You get the idea. 180-degree angle right there. There's A prime. So the last thing to do is connect those dots and identify the coordinates. Whoops. Identify the coordinates. A prime is 4, negative 1. B prime is 1, negative 4. C prime is 2, negative 1. And in terms of the lesson, that is all. So hopefully what you saw is that we didn't really talk about the symbolic notation. I personally don't think that it's necessary for the amount of time and frequency of problems that you're going to see on the assessment. It's really not necessary to know symbolic notation. What is important to know is which direction am I going, clockwise or counterclockwise? How many degrees am I going, 90, 180, or 270? We didn't have any examples with 270, so be careful with that on the homework. Ask questions if you need to. And is it about the fixed point on the figure, or is it about the origin? So those are the main pieces that I think you need to be concerned with. So you should be working on guided practice right now. I personally don't mind if you do that with a partner. Let me see, because I exited out of this other document that I had, so let me just make sure that we're all on the same page. When your guided practice is done, you know the drill. Tear it out, turn it in, make sure your name is on it. So the guided practice then is page 478, 1 and 2. Knock that out, tear it out, turn it in. Then you have some optional activities to work on. You could do your homework, which is page 479 all, or you could work on these or other IXL topics. And again, I hope to be back tomorrow, Wednesday that is. Just having trouble shaking this fever and have other symptoms. I went to the doctor, they couldn't find anything wrong, so it's just a matter of some sort of virus that has to run its course. So again, hopefully I'll see you Wednesday, and have a great day. I look forward to being back with you very soon.